Hey, what's up, guys? This is Chung here again. So this time, LeetCode number 2002. Maximum product of the length of the two palindromic subsequences. Right. So LeetCode finally reached 2000 problems. That's quite a lot. Okay, cool. So you're given like a string S, right? And we need to find the two disjoint palindromic subsequences of S such that the product of their length is maximum. Right? So the two subsequences are disjoint if they do not share a same index. Okay, and return the maximum possible product of the two. Yeah, so that's it, right? So for example, we have a LeetCode com and output is 9 because uh, so one optimal solution is we choose this ETE, right? ETE as a like first palindromic subsequence and CDC as the second one, right? And then the product of them is 3 times 3, which is 9. Okay, right? And this for this one is 1, right? This one is 25, so on and so forth. So the constraint is like only 12, right? So what is this telling us? It's telling us we should use like a Bitmask to enumerate all the possible 2 to the power of n subsequences, right? That's a strong hint of this solution for us, right? So which means actually it's pretty straightforward. Basically, since we have a length of this s here, it will have like in total of 2 to the power of n subsequences, right? And we just need to find all the palindromic subsequence among those 2 to the power of n subsequences, right? And then we'll basically try to find a disjoint pair, right? And then if those two pairs, basically if those two palindromic subsequences are disjoint, right? And then we can just try to get the product of them, right? And then how can we quickly check if two subsequences are disjoint, right? So what we can do is we can use a Bitmask, right? So for example, we have this 1 0 0 1 0, right? This one means that so we have this string here, right? Yeah. So if here we have a 1 here, it means that this index, this ladder, uh, so basically we're looking at this ladder, right? And here we have 0, 1, 2, 3, 4, 5. Basically here we have this 0, 1, 2, 3, 4, 5. So basically, so for this subsequence, we're looking at this subsequence, this bit mask representing, we're picking this the second one and the fifth one character as a subsequence, right? And then let's say we have this subsequence. Let's say for another one we have this 0 1 0 0 0, right? So this is a second subsequence, right? S1 and S2 here, right? So how can we quickly check if those two are disjoint? So we can just do a bitwise AND, right? If the bitwise AND equal to 0, that means that there's no shared ones, because otherwise if this one has like a 1 at here, then if we do an AND, the result will not be 0, right? So this is basically a trick to quickly check instead of compare those letters one by one, right? So I think that's it, right? Basically, we just need to go through all the possible 2 to the power of n subsequences, and then we check each of them if they are like uh they're palindromic or not, right? If it is, then we save both we can save the length, right? Save the length or plus the bit mask along with the length together, so that we can do a cross for loop later on, right? To check all the possible pairs. Okay. Let's start coding then, right? So n is the length of s, right? So um, I use a palindromic. I use PLs to save all the possible valid palindromic subsequences, right? And then for a mask in range of 1 to this, right? Basically, we loop through from 1, and then we end with 1, 1, 1, 1, 1, right? So we start 1 because we need at least one letter, right? So we have we have a subsequence, right? Starting from this one, and then we have uh, for I in range of n, right? We do this. So if the m and this I does not equal to 0, so here we're simply just find all the one in this mask, right? If it is, then I will append this one to here, right? And then in the end, I check if this one is a palindrome or not, right? So I just do this. I just do a comparison with the reverse version. If it is, and then I insert it into the list with the palindrome itself, and then plus m, right? Actually, all we need actually is the length. We don't even need this. We don't need this palindrome itself. So let's do a length of that. Okay, right? Okay, so now after this for loop here, so we have all the valid palindromic subsequences along with its length, right? Stored in this list here. So here we can just do a cross for loop here, right? So this is L1 actually, so length 1, right? For P length 2 M2 in pals, right? So we do a if M1, right, and M2 is equal to 0, right? Then we can update the answer. Okay. So we have answer starting from 0. Max of answer dot length of L. Sorry, actually we don't need the length. Sorry, L1 times L2, right? And that's it, right? Okay. Yeah. That's it, right? I mean, it's so the time complexity. I believe so. The first one is like what is 2 to the power of n times n, right? So we have this, but here actually, the worst case scenario, right? Like as you guys can see, so if we have everything is equal to the same, right? Everything is a, right? Then actually here's a 2 times of n times 2 to the power of n, right? So this is the time complexity for this one. Although we can do a little bit of improvements here, right? But I don't think it will affect the final time complexity. So when I say improvement here, we can simply do like this. So I think the first one is that before doing the second for loop here, right? We can check. Uh, we can check if we have the L1 here, right? So if the L1, right? If the L1 times n minus L1, right? It's greater than the answer, right? And if it is, then we can do a second for loop, right? Because the L1 times n, that's n minus L1 is the biggest length we can get from the second for loop here, right? So if this is smaller than the answer or equal to the answer, then there's no need to do a for loop here, right? So this is the first improvement, right? And second one, what's the second one? The second improvement is that let's say we have the first mask equals to like this, right? So for the second for loop here, we don't theoretically we don't need to loop through everything, right? Basically anything that is subset of this one, right? We don't need that, right? But so what does it means that since we don't we need all we need or we only need a disjoint, it means that we cannot have one on this bit position. which means we need a reversed mask from this one, right? And then we just need to do a subset enumeration of this reverse set from the second for loop, assuming this is M1, right? So this is a second improvement we can do, and as for how can we get like a reversed bit mask based on the current one, right? We can just do a like what we can do a bitwise OR, right, with the O1 here, right? So if we do a bitwise OR for this one, if they're the same, this is going to be 1. They're different. Sorry, if they're the same, it's going to be 0. If they're different, it's 1, right? 0, 1, 1, 0, right? So that's how we do it. And so once we have this a reversed mask, how can we enumerate the sub mask for this one? So there's a like small trick for this. So basically what we can do here, there's like a small trick here. So we do this. So while a current, right? So we something like this. If current is greater than 0, so let's say the current equals to the reverse, right? Reverse mask. Okay. Well, this one is equal to 0. We do what? We do current equals current minus 1 and times mask, right? So this is how we do enumerate the sub mask given like a mask. So when I say sub mask, it means that let's say we have this one, right? Okay. It means that when it is 0, we'll never have like a 1 at the position of 0. So we're only gonna have like some like zeros on the existing ones. For example, this is one of the sub mask, okay, and this is another one, okay, right, and this is another one, 1 0 1 1 0 0 1 0 0 0 0 1 1. So sub mask means that only some ones will be replaced by zeros. Okay, yeah, so that's how we enumerate the sub mask. Okay, and yeah, so that's some basic some I think 2 improvements we can make for the second for loop here. But in my opinion, it will not affect the total time complexity. That's why I'm just leaving. I'm not coding it here. Yeah, I think that's it, right? I guess that's everything I want to talk about for this one. Cool. Oh, and sorry, and the last thing, if I ever want to do the improvement of this reverse mask, we cannot use this list because once we're doing this one, what we have is a mask, right? Which means we need to use the mask to find the length, right? As you guys can see, so here I'm only storing this mask along with this length. So what we will do is that we will basically will have like a dictionary instead of a list here, where the key will be the mask and the value will be, I guess, maybe the length, right? That in that way we can use this the submask to find the length to do the calculation later on. Cool. I think I'll stop here and thank you for watching this video, guys. Stay tuned. See you guys soon. Bye bye.